Today's topic is about electrical fundamentals, basics of electrical. What is voltage? What is the unit for voltage? What is current? Ohm's law, Kirchoff's law, a German Kirchoff has found this law from electrical circuit. Then what is Faraday's laws of electromagnetic induction? Very basics about electrical. So we'll go into these topics today. The first one, what is charge actually? Electrical charge. So electricity is the movement of electrons. Whenever there is a movement of electron, we say the flow of current is taking place. So electrons is creating these charges. The definition for what is voltage is, the voltage is the difference in charge between 2 points. Suppose if I am connecting one resistor, so what is the voltage across these 2 points? A resistor is connected like this. What is the voltage across these 2 points? That is the voltage. So the difference in charge between the 2 points is called voltage. Its unit is volts. And we have electromotive force also. That is the source voltage. We can connect a voltage like this. So this voltage is used to drive the current. This type of voltage is called as electromotive force. That is the voltage which drives the current. Normally what is voltage is the difference in charge. So here also starting and in this point we have a difference. The difference in charge between the 2 points is called as voltage and its unit is volts. Second one is what is current. Current is a rate at which the charge is flowing. The rate of change of the charge is called as a current. How fast it is going. So that unit is called as ampere. And resistance is the material tendency to resist the flow of charge. So that is called as the resistance. That is the opposition of current. We say that is an opposition of current. We have some resistance, the body have some resistance, body resistance, cable have one resistance, copper have one resistance that will resist the flow of current. Metals have one resistance, insulators have a resistance. So that is the opposition of current is called resistance and its unit is ohms. And we have one small example for this. Suppose a pipe is drawn. So I will take a pipe like this. In this pipe, water is flowing inside this pipe. This is flow of water. Just imagine this is flow of water. Water is flowing inside the pipe. So the flow, this line you see, the flow is called as the current. The flow is called as the current. And that is measured in ampere. The flow is having a pressure. Voltage is nothing but that drives the current. If voltage is increased, the flow of electrons will increase. The movement of electron is called as the flow of current. So the pressure is nothing but it is the voltage. So if the water is flowing very fast, the pressure is high, the voltage is high. The voltage drives that water, that drives the current. Okay. So resistance, suppose the pipe is like this. If the pipe is becoming narrower like this, the pipe is becoming narrower. Here the flow will be good. When it comes to this end, the flow is less. So that way, that resists the flow. A simple example how water flows through the pipe. A different pipe, that narrowing, different friction of the pipe, that will resist the flow. That is called as the opposition. That is called as the resistance. And that unit is ohms. This is basics. So any atom which is consisting of nucleus which consists of protons and neutrons and that is revolved by the electrons. The outermost shell is having electrons. That electrons has to freely jump from the valence band to the conduction band. that movement is called, that the flow of charge carrier is called as the current. The rate of change of flow, that is flowing of current, is called. So this is what is voltage, what is current, what is resistance. Very basic for the electrical. I hope you might have understood. We'll clear all the drawings. We'll go for the next slide. Next is Ohm's law. Ohm's law states that at constant temperature, there is no variation in temperature. At constant temperature, voltage is directly proportional to current. V is directly proportional to current at constant temperature. We have to be very important in this definition. If the temperature changes, this both will not be proportional. And when we want to remove the proportionality constant, then we add R. Then it becomes V is equal to IR. R is a constant, proportionality constant, that is called as the resistance. So from this, we can find other parameters also. We can find what is V, what is R, what is I. So 3 formulas we can write from this. IR is equal to V. Likewise, we can write IR is equal to V. So I is equal to V by R. So any electrical circuits, if they are giving other 2 parameters, you can find the third one. It's very easy to find it. So Ohm's law states that at constant temperature, voltage is directly proportional to current. To remove the proportionality constant, we are using a resistance R. The resistance depends upon the conductor, depends upon the dimension of the conductor. Okay, so different conductors have different resistance. So that will depend on this. Okay. So our third definition is also over. Next one is this. Next is called, it's not moving. Yes, Kirchoff's law. So Kirchoff's law states that it is a law of conservation of current and energy. That is called as law of conservation of current and energy. So these 2 laws are commonly called as Kirchoff's current law and Kirchoff's voltage law. So what do you mean by Kirchoff's first law? First law is also called as Kirchoff's current law. So this current law, the algebraic sum of every current entering and leaving the node is equal to 0. We see this diagram. In this diagram, this is the node point. The current entering is the current coming inside. And when the current is moving out, that is exit, that is leaving from the junction. The current is leaving from the junction. From this diagram, I1 is entering towards the node. And I4 is going away from the node. Correct? Can show like this. I1 is moving towards the node and I4 is moving away from the node. So this algebraic sum is addition of all these towards this node is equal to 0. Current leaving and current entering, algebraic sum plus or minus, that is equal to 0. The current entering the node is equal to current leaving the node. So from this diagram, we can write I1 is entering. I1 plus I2 is entering. Please check this arrow mark. Arrow mark shows towards the node. So I2 is entering, I3 is entering, I4 is moving away. So minus I4, I5 is moving away. So minus I5, that is equal to 0. So Kirchoff's first law is also called as Kirchoff's current law. The algebraic sum of current leaving the junction and entering the junction is equal to 0. So the Kirchoff's law. This property, Kirchoff's law, is commonly called conservation of charge. conservation of energy, conservation of charge, conservation of current. These are different names which is given to the Kirchoff's first law. So all are same. Definition is similar. So I hope you might have understood about the Kirchoff. Kirchoff's is having two laws. First law, second law. The first law, current law, and the second law, voltage law. Two laws we have. So after clearing the diagram, can move to next slide. Kirchoff's second law or Kirchoff's voltage law. So this is the algebraic sum of every voltage in the loop has to be equal to 0. Same algebraic sum of voltage is equal to 0. See, here we have drawn an electrical loop circuit. With this voltage AB, AB is here. What is the drop across here? Voltage AB plus voltage BC, the drop across this resistance. Voltage BC, voltage CD, drop across this, and voltage DA, so drop across here. So all is equivalent to 0. So this is the definition for conservation of energy. So note this loop, the current loop should be from the clockwise direction or should be counterclockwise direction. The direction, the flow of voltage should be in this direction, flow, see? Or otherwise it should be in the counter direction. If the direction changes, this formula will not obey. So the algebraic sum of voltage drop of every circuit, for every resistance here is equal to 0. This is called as Kirchoff's law, conservation of energy. Hope you understood the Kirchoff's second law. It's all like definitions. We have to solve some problems regarding using this circuit analysis, circuit solvings that we have to do. So we have cleared this drawing and we will go for the next slide. So this is Faraday's law. Faraday's first law. Faraday's law of electromagnetic induction. So this Faraday's law of electromagnetic induction, this is called magnets. One magnet is North Pole magnet, one is South Pole magnet. In between the two magnets, there is a magnetic flux. Magnetic field is present between this North Pole and South Pole. Magnetic field is present. A conductor is placed in this magnetic field. Okay. So a conductor is placed between these two magnets. So what will happen? The twisting a torque is produced, force is produced. And there is a relative motion. Due to that force, the conductor moves. The conductor moves. And it cuts the magnetic field. When the conductor rotates, it cuts the magnetic field and EMF is induced in the conductor. So that is called as electromagnetic law, Faraday's laws of electromagnetic. So North Pole, South Pole is placed. In between this, we have a magnetic field. A conductor is placed here. So because of the twisting and turning force, the conductor starts to move and the conductor cuts the magnetic field and EMF is induced in the conductor. It is the first law of Faraday's laws of electromagnetic induction. Conductor is moving, magnet is stationary. So here this diagram is conductor is moving, the conductor rotates. Because of the relative motion between the conductor, it rotates. And here the magnet is moving, the magnet is rotating, Conductor stays in the same place as stationary. So this is Faraday's law. This is what the formulas we are using for machines, how the machine is rotated, how the EMF is produced, how it's generating the voltage. So everything comes from this law. Hope you understood this. And we go for the next one. Next one is Faraday's law's second law. So now the EMF is induced. So now the magnitude of induced EMF is equal to the rate of change of flux linkage. There is a flux linkage. Flux will drive a torque, a force, and that will make to rotate the conductor. So that flux linkage, we write it change of flux with respect to time. Rate of change of flux. Rate of change, it will be always with respect to delta t. So from this equation, EMF is equal to N delta flux divided by delta t. So change in flux. The N is called as number of loops. Rate of change of flux with respect to time. If minus is present, and that is called as the Lenz law. What do you mean by Lenz law is, this induced EMF will start to oppose the cause of producing. It opposes the main voltage, main current, main voltage. So that is, it starts to oppose. So what happened to in the case of motor, the speed will get reduced because the produced EMF will become a counter EMF, back EMF, and it opposes the source itself. That will become a drawback in motor. EMF should be generated in a generator. If EMF is generated in the motor, then that will become a problem like Lenz law, minus. It opposes the source. We don't want to go very deep here. We want to know what is the definition. So the second law states that the magnitude of induced EMF is equal to the rate of change of flux linkage. So the equation is equal to N delta psi divided by delta T, change in flux. This is up to the basics of electrical. Hope you all understood. Thank you. The part 2 portion will come with what is magnetic flux, self-induction, transformer, mutual induction, principle of transformer, those things, basics. We'll start in the next slide. Thank you all for listening.